Let's learn how to simplify, add, and subtract rational expressions. So we're going to first learn about what a rational expression is. We'll talk about terms versus factors. We'll be simplifying along the way, which will mean we have to factor. We'll be adding and subtracting fractions, which means we're going to have to get a common denominator. And then we're going to limit the domain as well. So let's get ready. You're going to need notes, pencil, and a calculator. And just take a look at these two things. If we look at them, the first one is just this fraction, and that is a rational expression. Rational means something that could be written as a fraction. So in this unit, we're going to be learning about fractions. It's an expression, there's no equal sign, and we can simplify, and that's what we're going to learn about today. For the second one, this entire thing has an equal sign, so this is an equation. We can solve it. We will be getting to that, but first we have to just figure out how do we simplify, how do we add and subtract without any equal signs. Looking at these, hopefully they look different to you. If I look at A, I see a quadratic trinomial. It's in standard form. Here's a quadratic binomial in standard form. So these are in standard form. And if I were to factor it, what multiplies to -8 and adds to 2, that would be 4 and -2. It's going to factor to this, x minus 2 and x plus 4. If I try to factor the bottom one, this is a difference of 2 squares, if we remember that. And I'm going to take the square root of the first term, which is x, the square root of the last, which is 2. One gets a plus, one gets a minus, and we have factored that. So the first one is in standard form, and each of these things are called terms. The second one is in factored form, and each of our parentheses are called factors. So we have factors and we have terms. Terms are added or subtracted and cannot be crossed off. So you're going to be tempted to do that. No, don't do that. No. Factors in B, they're being multiplied. So if they are exactly the same, we can simplify. So I have an x minus 1 and an x minus 1 and x minus 2 over x minus 2. Those are going to simplify to 1. So we can cross them off. So factors can be crossed off, terms cannot. What not to do. So I see these x squareds. Oh, I'm going to cancel them. I see the 16s. I'm going to cancel them. What are we going to call this? Like 4 plus x? I'm not sure. But no, that is not what it equals. Because that would be like taking this fraction, which if I did order of operations and did my addition, which is my grouping, this is going to be 8/9. That is correct. But if somebody wants to think that they can cross off the 6, then they're going to do 2/3. Those are not the same, so it's not 2/3. Everything here was separated with addition signs or subtraction signs, so these were terms, and you cannot cross off terms. All right, so let's look at how we can do it instead, because we know we can't cross off the x squareds, we can't cross off the 16. I gave you a little taste earlier, and we are going to be factoring. We're going to be factoring all types of things, trinomials, binomials, greatest common factor. So if I look at the numerator, this would be a GCF. I can take out a 4x. It leaves behind an x plus 4. My denominator is going to be a difference of 2 squares. So I'm going to factor that, and that factors to x minus 4 and x plus 4. So notice I've changed it from standard form and terms to factored form and factors. And this is where I can now simplify. So when I have the same exact factor in the numerator as the denominator, they're going to simplify to 1. And then I end up with this answer, which is just 4x over x minus 4. That's my simplified answer. Again, you cannot cross off those x's. You can't cross off those 4's because now we're back to terms. Another thing that we're going to talk about is limiting the domain. Because we're doing fractions, we don't want to divide by 0. So if I had some number divided by 0, that is not possible. 0 divided by a number is 0. But if I had a pizza and I want to divide it between 0 people, that's not a thing. So this is undefined. 0 in the numerator is okay. So now if I look at my denominator, technically this is my original denominator. I think it's easiest to figure out your domain from your factored denominator. And I don't want either of those parentheses to equal 0, because if they do, then I have 0 times something, which would be 0. So if I set the x minus 4 equal to 0 and the x plus 4 equal to 0, then x would be 4 and x would be negative 4. Those are the numbers I don't want to plug in, so I'm going to say x can't be 4 and x can't be negative 4. Now you might say, but you crossed off the x minus or x plus 4. Why do you need to include that? Even if you cross it off, it's still important because you come back to the original. And so if I cross off this negative 4, but I plug it in here, negative 4 squared is 16. 16 minus 16 is 0. It will still make it 0, and I can't even do the original problem. So you have to look at your entire denominator before you cross anything off. So I would say my answer is 4x over x minus 4, and include the limit to the domain that x can't be 4 and x can't be negative 4. Let's try this one. Here we have both quadratics. They are trinomials. They're in standard form. Please don't cross off those x squareds. In my numerator, I'm going to be thinking about what multiplies to negative 10 and adds to 3. So that's going to be 5 and a negative 2. My a is 1, so I can go right to my parentheses. And the numerator factors to x plus 5, x minus 2. In the denominator, I'm doing what multiplies to negative 2 and adds to negative 1. That's going to be negative 2 and a positive 1. So my denominator factored is x minus 2 and x plus 1. Again, this is standard form. Do not cross off there. Those are terms. This is factored form. And now we can simplify. Anything that you have in the numerator, if it's exactly the same, it's going to simplify to 1. So I can cross off those x minus 2's. And I get this to be simplified to x plus 5 over x plus 1. Don't cross those x's off. And I need to limit my domain, both pieces. So we say x cannot be 2 or negative 1. Now let's talk about adding and subtracting. We were just simplifying. So we're going to go back to the beginning when you add fractions. And in order to add fractions, I need to get a common denominator. So with the 2 and the 3, I'm trying to think of the common denominator. It would be 6. So I want to rewrite them both with a common denominator of 6. So in order to do that, I need to figure out what the missing factor is. What do I have to multiply 2 by to get 6? And that would be 3. Well, I can't just multiply part of a fraction by that. I have to multiply the top and the bottom by 3 because 3 over 3 is 1, and I'm not changing the problem at all. So my numerator becomes 3, which should make sense to you because 3/6 is 1/2. For the second fraction, what do I have to multiply 3 by to get 6? I have to multiply it by 2, which means I have to also multiply the 5 by 2, and I get 10. And now that I have my common denominator, I'm going to add the numerator, so I get 13. And please remember, your denominator just stays 6. You don't add it, you don't multiply it, it's just 6. That's my final answer there. Let's look at B. So my denominator parts are an x and a 7. So if I were to ask you what is the greatest common denominator, it would be both of those, 7x, 7 times x. So I want to rewrite my first fraction so it has a 7x, and my second fraction so it has a 7x. So when I look at my first denominator, which is x, it needs to be multiplied by a 7. So I have to do that on top and bottom, and 7 times 5 is 35. When I look at my second fraction, it needs to get multiplied by an x, which means my numerator needs to get multiplied by x, and 4 times x is 4x. So now I have a common denominator. I can add my numerators together, and I get 35 plus 4x. Remember, you can't combine those. One has an x and the other one doesn't. And then keep your denominator as 7x. Now notice I do have a variable in my denominator, and I still don't want my denominator to be 0. So we have to limit this domain and say that x cannot be 0. And in C, I have a whole number plus a fraction. So think of that whole number as over 1, if that helps. I'm going to look at my denominators and see what I can make for a common denominator, and it's going to be 3x. So this time my second fraction is all set. I don't need to change that, but I do need my first fraction to have a 3x for the denominator. Well, it doesn't have any of that, so I have to multiply the top and the bottom by 3x. So 8 times 3x is 24x. My second fraction stays the same. I combine my numerator with adding, so I get 24x plus 2, and I keep my denominator the same as 3x. I'm going to limit the domain so x cannot be 0. So when you add or subtract fractions, you have to get a common denominator, multiply the numerator or denominator by the missing factor. What's missing? If it's 2 and you're going to 6, then you have to multiply by a 3. Combine your numerators, but keep the denominator the same. So let's look here. We're now switching to subtraction. My denominators are 2 and x cubed. So my common denominators would be both of those things, 2x cubed minus 2x cubed. So when I think about what's missing, each one is missing the other factor. So this first fraction needs to get multiplied by x cubes, and my second fraction needs to get multiplied by 2's. X cubed times x to the 1, we've done that before. That's multiplying. That's our rules of exponent. So we add our exponents and we get x to the 4th. And then on the second one, I just get 2. Now I have a common denominator, so I combine my numerator for 4x minus 2 all over 2x cubed, and x still cannot be 0. Let's look here. So here I have an 8 times x. So that means that's an 8 and an x. In the second one, I have 8x squared. That means that's an 8 and an x and an x. So you don't want to go too big. You can, but then you have to simplify at the end. So just think about what is my greatest common factor. They both have an 8. They both have an x. The first one needs another x. And once it has that, then they would have the same denominator. So my common denominator is this piece, 8x squared. So I'm going to write 8x squared for both of my denominators. That means I don't have to change my second fraction. But my first fraction needs to be multiplied by another x, top and bottom. So I'm going to multiply 1 by x, and I get x. And my numerator combined is x plus 3 all over 8x squared. In this case, I don't want my denominator still to be 0, but I could plug 0 in. No, I can't. Sorry, x can't be 0 there, because that would still give me 0. All right, adding and subtracting. So we've got a 4 and an x and a 7 and an x. They both already have an x. You don't need another x. So let's think about the greatest common factor between a 4 and a 7. Not greatest common factor, common denominator between 4 and 7. It's going to be 28. So I want my first fraction to have a denominator of 28 and my second one to have a denominator of 28. So that means the first fraction needs to get multiplied by 7 over 7, and the second fraction needs to get multiplied by 4 over 4. So then I have 49 plus 12, and when I add those together, I'm going to get 61 over 28x. X cannot be 0. And our last problem, let's take a look at this. We've got different variables. So if I break it down, this one has 3 y's. This one has 2 x's and 3 y's. This is my common denominator. So it has everything, that second fraction. The first fraction is missing the 2 x's. So I need to multiply by x squared on the top and the bottom. So my denominator will be x squared y cubed for both of them. I know my second fraction's all set. My first fraction, I need to combine those, and I'm multiplying, so I add my exponents and I get x cubed. And then I'm going to add my numerators, so I get x cubed plus 1 all over x squared y cubed. In this case, we'll say x and y cannot be 0. And we did it. So we simplified and we added and subtracted, and it is just fractions, so we have to get common denominators. Nice job.